All right, so you should have two papers, a gold and a blue, and we are going to look at graphing reciprocal functions, the reciprocal trig functions today. Your assignment for today is in Delta Math. It's just going to be reciprocal values. You're not actually going to do any graphing. We're going to do the graphing tomorrow, kind of in class, okay? All right, so we're going to start here. So find this, cosecant. Not cotangent, cosecant. Careful. There you go. You're going to be mad at yourself if you do it on the wrong one. Okay. It's the side that has two graphs. Okie dokie. So cosecant is the reciprocal of what? Sine. Okay, good. So cosecant of x is equal to 1 over sine x. Right? So the parent function is f of x equals cosecant x. All right. So look to y'all like that's flashing or something, like dimming or, okay, making sure it wasn't just my brain or something. All right, cosecant. So the way we're going to get cosecant is from sine, because we know how to graph sine. So we are going to sketch in, like lightly, you can just like do a little dotted line of a parent function for sine. So I'm going to make a couple points that I can actually hit here. I don't know why it's doing that. I think it's going to give me a headache before the end of the period. I don't think it was doing that last period. Okay. So there's your sine. It's kind of in the background, right? We're not going to have to do this every time. We're just going to do it to get our values in here. Bless you. Okay. So when we're at 0, the sine of 0 is 0, which means the cosecant is what? What's the reciprocal of 0? Undefined. And what's that going to look like on the graph? Asymptote. Okay, so where sine is 0, we have an asymptote for cosecant. So that means everywhere that sine is 0, we have an asymptote for cosecant. So I'm going to put one there and one there as well. Okay, make sense? All right, so then we can look at pi halves. The sine of pi halves is 1. So what's the cosecant? 1. The reciprocal of 1 is 1. The sine of 3 pi halves is -1, so the cosecant is -1. All right? See how the sine function can help us with this? Now, if you've never seen the cosecant before, this is probably not enough. Thank you. Okay, thanks. So we're going to get a couple more points in here just for this one time so that we can get the idea of what's going on. They're approximate values, so we wouldn't graph them every time, but we've got to figure out what this is really going to look like. So here, this is pi fourths. What's the sine of pi fourths? Square root of 2 over 2, which is about right there, right? So that means the cosecant is what? Square root of 2. Square root of 2 is about 1.4, okay? So at pi fourths, the cosecant is square root of 2, which is about 1.4, so we're going to graph about 1.4. And my board, like I said, is being extra weird today. I don't know. So, and remember this, when I talk about quadrants, yes, we have quadrants 1, 2, 3, and 4 here, but we don't care about those. The quadrants that mean something to us are the quadrants for the unit circle. So when I get to 3 pi fourths on the unit circle, I'm in the second quadrant. And the second quadrant is sine and cosecant positive or negative? What is it? All students take calculus. Is it positive or negative? Positive. So the sine of 3 pi fourths is a square root of 2 over 2, which means the cosecant is square root of 2, and I'm up here. 5 pi fourths is in the third quadrant, so that would be negative square root of 2 over 2, which means it's negative square root of 2 right here. And you see how you can tell from this graph here? As far as the unit circle is concerned, this is the first quadrant, this is the second quadrant, sign is positive, positive. This is the third quadrant, this is the fourth quadrant. That's from the unit circle. So negative, which means this would be negative square root of 2, like that. Because we know what's going on, what happens with asymptotes, that we have to be going from negative or positive infinity here, and we have these 3 points, your curve looks like this. It looks like a parabola. It is not a parabola, but it has the same basic shape that you would think of as a parabola, and not the weird crooked thing that I just drew. So you see how we kind of took sine and turned it inside out? That's basically what happened. Okay? So now we can repeat this. I have an asymptote every pi. So I have one here and one here. And then at negative pi halves, I'll be at negative 1. And at negative 3 pi halves, I'll be at positive 1. And like I said, we don't have to graph the 1.4 stuff now that we know what it looks like and what's supposed to be happening here, that it's not something like a tangent looking. It's going to go like this and like this. Okay? And that is cosecant. We good? Yes, sir. No. Because really what you're more worried about than getting like a perfect graph is getting, you know, which direction are things going? Are we positive? Are we negative? How does it move? That's the more important part of it. That's a good question. All right, so let's fill in this stuff here. Domain. Well, clearly not all real numbers because I have asymptotes. So it's going to look weird like it did for tangent. So my domain is the set of all x's such that x cannot equal, well, it can't equal 0 or pi or 2 pi or 3 pi or 4 pi. So it can't equal n times pi, where n is an element of the integers. Do I have any zeros? No. And remember from tangent that the domain and the asymptotes are directly related, because the domain can't be where we have asymptotes, so our asymptotes we've basically already defined. They're at x equals n times pi, where n is an element of the integers. Is my range all real numbers? No. I start at negative infinity and go to where? Negative 1. Do I get to include negative 1? Yes. And then I start back over where? 1 and go to infinity. Do I have a y-intercept? No. Amplitude does not exist because there's no maximum and minimum, right? And what's the period? 2 pi. It's the same as sine, right? Because we're taking sine and turning it inside out. So period is 2 pi. Okay. My transformations, f of x. Oh, goodness. F of x equals a times the cosecant of b times x minus c plus d. So a, we still take the absolute value of that. That is still your vertical stretch or compression. The period is still 2 pi divided by the absolute value of b. Frequency is still the absolute value of b, and if you need to find it, it is 2 pi divided by the period. So the 2 pi always goes on top. You either divide by the period or divide by b, depending on what you're looking for. Horizontal or phase shift is still c. Vertical shift is still d. Spin line, y equals d. Okay. Questions? All right. Let's look at, I did forget something here. The parent function that you're going to sketch when you graph this is sine. And then we're just going to know to do the opposite stuff, right? Everywhere you have a 0, you have an asymptote. Everywhere you have a 1, you have a 1, that type of thing. That way you only have one little one to remember for both of them. All right. Secant. What is secant the reciprocal of? Cosine. So the secant of x is equal to 1 over the cosine of x. Of x equals secant of x. So we are going to sketch lightly a parent function, one cycle of parent function of cosine. I'm going to put in some points here so I have something to hit when I'm trying to sketch this in. But this is just kind of a background thing that we're not going to sketch it on the main graph every single time. We're just going to do it so you can see how it works. Okay. So the cosine of 0 is 1, and the reciprocal of 1 is 1. Remember how hard that question used to be? Okay. And then I also have a 1 over here. The cosine of pi is -1, so the secant of pi is -1. The cosine of pi halves is 0, so what is the secant of pi halves? Undefined. So where cosine has a 0, we are going to have an asymptote. Both places. Those are your 5 pieces. You have 3 anchor points and 2 asymptotes. Okay? Then let's just go ahead and repeat that before we sketch it in, because this one doesn't work as nicely. So there's where my asymptotes repeat. Then this was at 1, so here I'm at -1, and here I'm at 1. We're not going to bother with the 1.4 points, because now that we know what it looks like I said, we can just sketch that in, because all cosine is a shift of sine. So these graphs should look the same, just shifted over, right? So here is what your secant graph looks like. Questions? Anything? All right. So my domain. Again, it's everything but the asymptotes. The asymptotes still happen every pi. They're just shifted over. It doesn't start at 0. It starts at pi halves. So I have to say that the domain is the set of all x's such that x cannot equal n times pi plus pi halves, where n is an element of the integers. Do I have any zeros? Nope. These two are directly related, so my asymptotes are at x equals n times pi plus pi halves, where n is an element of the integers. Is the range the same as it is for cosecant? Yes, it is. So I'm going from -infinity to -1, and then 1 to infinity. Do I have a y-intercept? Yes, I do. It is at 0, 1. Amplitude still does not exist. What's the period? 2 pi, just like it was for cosine. Okay, sine and cosine are 2 pi, secant and cosecant are also 2 pi, right? My transformations, f of x equals a times the secant of b times x minus c plus d. By now, hopefully you could just fill this stuff in without me. A is still absolute value of a. Well, I can't even fill it in myself. Absolute value of a, still your vertical stretch or compression. Period. This would be 2 pi divided by the absolute value of b. Frequency is the absolute value of b, which is also 2 pi divided by the period. C, D, y equals D. Okay. Good. Your parent function for this that you would sketch in would be cosine. And then we just do the opposite of it. Okay. Questions about secant? All right, let's look at cotangent. Cotangent is the reciprocal of what? Tangent. So the cotangent of x is equal to 1 over the tangent of x. F of x equals cotangent of x. All right, so we are going to sketch in over here one cycle of tangent, which means it looked like this, using our tangent parent function. All right. Okay, so when tangent is 0, what is cotangent? Undefined. So that means everywhere tangent is 0, I have an asymptote. Right there and right there. At pi halves, tangent is undefined. What's the value of cotangent? 0. So where tangent has an asymptote, cotangent has a 0. At pi fourths, tangent is 1. So what is cotangent? 1. 3 pi fourths, tangent is -1. So cotangent is -1. That means this is what cotangent looks like. So not necessarily inside out like the other ones. It's reflected and translated over. So it looks very much like tangent. Once we have that, then we can just repeat it, right? So I'll have an asymptote at 2 pi, one at -pi, and one at -2 pi. There you go. Your parent function that you would sketch in would be tangent, just like you did for tangent. Okay, so we're just going to be consistent. The only parent functions we have are sine, cosine, and tangent, and then we just know how to use them to graph the others. Okay, we good? All right, so domain. Well, got the asymptote thing again. All of the They're all the x's except for where I have my asymptotes. So it is the set of all x's such that x cannot equal n times pi, where n is an element of the integers. Do I have zeros here? Yes, I do. I have an infinite amount of them. And they happen every pi, but it starts at pi halves. So I would say it's the set of all x's such that x does equal n times pi plus pi halves, where n is an element of the integers. Yes? Then I should be able to get my asymptotes. That's going to be x equals n times pi, where n is an element of the integers. What's my range here? Negative infinity to infinity. Good. Do I have a y-intercept? No. Do I have an amplitude? No, because I don't have a maximum or a minimum. Right? What's the period here? Pi, just like it was for tangent. Okay, so tangent and cotangent are pi, all the rest are 2 pi. So my transformations, f of x equals a times the cotangent of b times x minus c plus d. Put them all in there. A, still not an amplitude, so it's the absolute value of A, still your vertical stretch or compression. Period, that is pi divided by the absolute value of B. Frequency is still the absolute value of B. If I need to find it, it is pi divided by the period. Make sure you keep in mind that you use pi for tangent and cotangent. And then again, C, D, and y equals D. Okay? Any questions at this point? It's none. The definition of amplitude is the half the distance between the maximum and minimum points, and we don't have maximum and minimum points. Does that make sense? Okay. Like the idea of amplitude, the idea of the A is 1, just because we're going up 1, but it's not officially an amplitude. Okay. All right, good question. All right, grab your other sheet of paper. We are not going to fill in these top 3 graphs because basically that's what we just did, so we're not going to spend time doing that again, but I do want to talk about some of this stuff. All reciprocal functions have vertical asymptotes, all 3 of them, okay? And reciprocal functions do not have amplitude, right? We're still going to have a vertical stretch or compression, but it's not called amplitude. And as a friendly reminder once again, the period of cosecant and secant for the parent functions is what? 2 pi. And the period for cotangent is pi. Okay. Don't forget that, because that'll mess up your entire graph. Okay, so let's identify, hopefully identifying this stuff regardless of whether or not it's a reciprocal function or whatever this part happens to be. You should still be able to fill that out over there. So A here is 3/2. Frequency is 1, which makes the period 2 pi. I don't have a phase shift. Y equals 0, right? That's all kind of a no-brainer at this point. So cosecant is the reciprocal of what? Sine. So my parent function I'm going to draw in over here is sine. And then I'm going to use that to help me get my graph over there. I'm going to go ahead and draw in my midline. Okay. My sine function starts with a midline 0, 0. The only thing that affects that is a phase shift, and I don't have one. So I'm still going to be on the axis. But instead of a 0, since it's actually cosecant, I'm going to have an asymptote. So I will have an asymptote here on the y-axis. I have another asymptote at the end of the period. The period is 2 pi, and I don't have a phase shift. So I put my asymptote at 2 pi. And then just like all the rest, half, half, half. Halfway in between, I have another asymptote, because that would be another 0. So that's here at pi. Halfway between these two asymptotes, on sine, I would go up 1. I don't have a reflection, but I do have a stretch of 3 halves. So instead of going up 1 from the midline, I go up 3 halves. So halfway between these two, from the midline, I go up 1.5. Halfway between these two, I go down 1.5. Oh, why it's doing that all of a sudden. Okay, then I just repeat. Okay. I'd also have an asymptote at negative pi and negative 2 pi and points here and here. Okay. And there is your cosecant graph. Any questions? All right, good. If you can do the rest, you can do these. You just got to think you're doing the opposite when you're plotting. Okay, so let's look at number 3. We've got negative, which means I'm going to reflect, so we got to pay attention to that. But A is still 1. Frequency is 4/3. So if the frequency is 4/3, what's the period? 3 pi halves. I don't have a phase shift, midline, y equals 0. Secant is the reciprocal of what? Cosine. So I'm going to sketch in a cosine parent function right there. And my midline is at y equals 0. Okay, so this point will be on the y-axis unless I have a phase shift, don't have a phase shift. On cosine, I go from the midline up whatever the A is, which is 1, but I have a reflection, so I'm actually going to go down. So from the midline, I'm actually going to go down 1. The end of the period has the same y value. The period ends at 3 pi halves. 3 pi halves, same y value. Right? Halfway between these two, from the midline, I'm going to be on the other side of the midline, whatever A is. So halfway between these two, which is right here, I'm going to be up here. Then, halfway between these 2 points, I'm going to have an asymptote because there's a 0, and I'm also going to have one right there. So, halfway between these two, asymptote right here, and asymptote right here. Then you have your 3 anchor points and your 2 asymptotes, and you should be able to repeat. Okay. Everybody good with that? Okay. Man. Oh, thank you. And it should look like that. And all agree? Got any questions? All right. Let's do a cotangent. My A here is 3. Frequency is 1/2. So what's the period? 2 pi. Good. Phase shift is 0, midline y equals 0. Cotangent is the reciprocal of tangent, so I'm going to draw him a little parent function there. And my midline is y equals 0. Okay. So, since this is a midline 0, 0, I will have an asymptote on the y-axis unless I have a phase shift. Don't have a phase shift, so I have an asymptote right here. I will have another asymptote at the end of the period. This period is 2 pi, so at 2 pi I have an asymptote. Halfway between the two, tangent has an asymptote, which means cotangent has 0 on the midline. Then halfway between these two, my parent function goes up 1, but my a is 3, so halfway between these two, I go up 1, 2, 3. Oh. And then halfway between these two, I go down 3. And then I repeat. Everybody okay with where everything came from and why? All right. This in here. Here, here, here. Okay. Any questions at all? All right. So let's look at 7. 7 has a phase shift. Do I need to factor anything out? No. Okay, so A is 1. My frequency is 1, which means what's the period? 2 pi. And which direction am I going in my phase shift? To the right. Pi fourths. And my midline is at y equals -2. Cosecant is the reciprocal of what? Sine. So I'm going to sketch him a little sine function and put it in my midline. All right, so this is a midline 0, 0, which means for cosecant it's going to be an asymptote. You go ahead and decide where that asymptote is going to be. Is it going to be on the y-axis? No, I have a phase shift, so I'm going to have to move to the right pi fourths. This is where that goes, right? The end of the period will also have an asymptote, but I have a phase shift. So the end of the period's at 2 pi, I can put my pencil there, but then I got to move to the right pi fourths. That is where the other asymptote is, or one of the other asymptotes. Then just like everything else, half, 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 so halfway between I'm going to have another asymptote, which would be right here. Then halfway between the first two asymptotes, from the midline, I go up 1. Up 1, or right there. And that means halfway between the two from the midline, I go down 1 here. Then I repeat. Any questions at all? Do you understand how to use the original parent functions to do the opposite to get these graphs? All right. Let's look at number 8. I have a phase shift. Do I need to factor anything out? No, because nicely it's factored out for me, right? So A is 2. Frequency is 2, so what's the period? Pi. My phase shift, I go which direction? left pi, and then my midline, y equals 1. All right, secant is the reciprocal of what? Cosine. Right, and my midline is here. Okay, so you go ahead, you get this first point on the graph. Decide where it's supposed to be, put it there, and I'll put mine there. We'll see if we all agree before we move on. I say it goes there. Do you agree with that? Yes? I went up 2, and then I had to go over pi. All right, so then get the end of the period on there. See, it's there. Do we agree with that? Okay. So halfway between the two, I'm going on the other side of the asymptote. So halfway between from the midline, not the asymptote, I'm sorry. I go on the other side of the midline. So halfway between the two from the midline, I'm going down to right there. Then what goes halfway between these 2 points? An asymptote, and then another asymptote here. And there are your 5 pieces. Everybody okay with where everything came from? Alrighty, so then we're just going to repeat. Any questions? Good? All right. Last one. What is A here? 1. What's the frequency? 2. So what's the period? Yeah, pi halves, because this is cotangent. And I didn't need to factor anything out. We should always look at that first, but it's factored out for me. I'm going to go to the right, 3 pi halves. Midline, y equals -3. All right, so cotangent is the reciprocal of tangent. So I'm going to draw in my little tangent parent function there and put in my midline. All right, so where tangent is 0, cotangent has an asymptote. I have a phase shift 3 pi halves. So I'm going to start on the y-axis, but I go to the right 3 pi halves. That is where that first asymptote is. The end of the period is also an asymptote. The end of the period is at pi halves, but then I have to move to the right 3 pi halves, and that's where that end of the period goes. Where tangent has an asymptote, cotangent has a 0. So halfway between these two, it is a midline 0, so it's right there. Be careful not to put it on the axis. Halfway between these two, I go up whatever A is, as long as there's not a reflection, so it's just 1. So I have 1 here and a -1 from the asymptote there. There are my 5 pieces. Then I repeat. look something like that. Any questions at all? All right, so remember, your delta math is you practicing your reciprocal values, and we will graph these in class tomorrow. Okay? We all good? Awesome. I can't pause it from back here. So